Welcome to Sheba Code. In this video, we will solve the easy dynamic programming problem on Leetcode within 3 minutes. The problem is as follows. Given an integer n, return an array of length n plus 1 such that the ith element of the array is the number of ones in the binary representation of I. Although this can be easily solved with built-in functions, let's try to solve it with dynamic programming dp. Here we define dpi as the number of ones in the binary representation of I. In this case, it is clear that dp0 equals 0. However, in order to calculate dpi, we need to come up with a state transition equation, which is a way of expressing how to calculate the value of a particular subproblem. In this case, dpi, using the values of smaller subproblems that have already been solved. This is a key part of the dynamic programming approach, as it allows us to build up the solution to the larger problem by solving and storing the solutions to smaller subproblems. In this problem, the state transition equation is as follows. dpi equals the sum of dpi divided by 2 and I modulo 2. Let's see how it works. First, dividing a number by 2 is equivalent to shifting its binary representation to the right by 1 bit. This is often called a right-shift operation. For example, if you right-shift the binary representation of 1, 0, 1, then the resulting binary will be 1, 0. In other words, dpi divided by 2 is an answer to a smaller subproblem where we solved for the number of 1 in the binary representation of I except for the rightmost bit. In order to take the rightmost bit into account, we then add I modulo 2. Let's take a look at an example implementation of the solution using C++. In this example, we first initialize a vector called dp with a size of n plus 1. Then we loop through each value of I from 1 to n and use a transition equation to calculate the value of dp at the ith position. The overall complexity for solving this problem using dynamic programming is O(n). This means that the time it takes to solve the problem is directly proportional to the size of the input integer n, making it a highly efficient solution. I hope you found the solution we presented to be helpful and easy to understand. If you have any questions or would like to learn more, please don't hesitate to leave a comment below.